here. And I'd like to say that it is super easy, but I'm not going to lie to you. It is basically putting all of those methods of factoring all together into one lesson. Besides putting them all together, we are also going to add one more method, which really isn't a method. We're just going to remind you that there are those perfect square trinomials that happen when you square a binomial. Excuse me. Remember, we talked about when we square a binomial, we can't just square this first number and square this second number and end up with a binomial, because when we FOIL it out, we get those like terms in the middle, and then we end up with a trinomial in the end. So we are just going backwards. What to look for on a perfect square trinomial is obviously the first term and the very, very last term have to be perfect squares. Not only the variable has to be squared or an even exponent, but then the coefficient out in front needs to be a perfect square, such as 1, 4, 9, 16, 25, and so on and so forth. And then you look at the middle number. And remember, that middle number is what you get when you multiply the square root of that first number and the second number, and then you're going to have two of them. Okay, so take a look at this example right here. This one is a perfect square trinomial. It is a perfect square because 16x squared would be 4x when I take the square root, and 9 would be 3. And then in order to get that middle number, I would have to take 4x times 3, which would be 12x, and I have two of them, and that works. So my answer is 4x plus 3. It has to be plus, the signs is the same and they're both positive, squared. So 4x plus 3 squared. Whether you choose to write it like that or you choose to write it as 4x plus 3 times 4x plus 3, just know that that's the same thing. Okay, so we are going to be introducing all kinds of stuff, including that perfect square trinomial. So the first part is just identifying whether or not it is a perfect square trinomial. Write yes, and if it's yes, you factor it. If it's not, you're done. So take a look at this first one. There's a good chance it's a perfect square because that would be 5n. 1 is always 1. Now 5n times 1 is 5n, and if I have two of them, then it works. Notice the signs are the same, but they both must be negative. So you have 5n minus 1 squared. Again, if you want to write 5n minus 1 and 5n minus 1, you can, but you do not have to. Okay, take a look at this one right here. We've got a 4a squared, so 2a, that's a perfect square. We've got a 16, so 4, that's a perfect square. But check this out. What's 2 times 4? It is 8a. However, I would need two of those in there, so that would have had to have been a 16 in order for this to be a perfect square. But before I do anything, you know what I forgot to do? Forgot that first rule. Can I factor something out? Yes, I can. I can take a 4 out, so let's try it again. A squared minus 2a plus 4. But guess what? It's still not going to be a perfect square because I would need a 4 in there. So this is a no. It's not a perfect square trinomial. All right, let's turn the page over. On the back of the page, we're going to keep going with these perfect squares. Just remember, the first step is to factor something out if you can. So take a look, and that's just more, it's talking about factoring out greatest common factor, and now we're looking for all sorts of things. Any way we can factor, whether it's a perfect square trinomial, we have got difference of squares, maybe we can group, whatever we can do. But the step one, can we take something out? In this one, yes we can. We can take a 3 out, and we get x squared minus 4x plus 4. Now, can we factor that? The answer to that question is yes. Same signs, both negative. I know I have x and x, and it is minus 2.